Good day, Miss. I am Laview Zain, and now we'll talk about treatment of dye in water. So first, I'll talk on the general statistics found. According to the United States Color Index, commodity dyes have reached tens of thousands. About 60,000 tons of dyes are discharged into the environment in the form of waste each year worldwide, and 80% of which are azo dyes. According to the data published by the National Bureau of Statistics, at present, China's fuel production and trade volume are ranked first in the world, of which 70 to 80% are azo dyes. According to incomplete statistics, the amount of wastewater discharged by textile industry is as high as 900 million tons per year, accounting for the sixth place in industrial discharge. In these printing and dyeing wastewater, the dye composition is complex, high concentration, and high color, which is difficult to biodegrade. Next, I will talk on the different types of dyes. Dyes are generally classified according to the two methods of application and chemical structure. So according to the chemical structure classification, dyes are mainly divided into 8 categories, such as azo dyes, indigo dyes, sulfur dyes, and so on. And according to the application classification, dyes are mainly divided into 14 categories that are reactive dyes, acid dyes, oxidation dyes, and the rest listed here. Now here is an example of a molecular structure of a reactive dye. It contains reactive groups which can form covalent bonds with hydroxyl groups on cellulose fibers, protein fibers, and amine groups on polyamide fibers under appropriate conditions. And once combined into a dye fiber as a whole, this causes it to be a reactive dye. Now I'll talk on the available treatments for dyes in water. But first, let's look at the technical overview. So basic raw materials for dye production are benzene series, naphthalene series, etroquinone series, aniline, and benzidine compounds. And in them are chelated with metals, salts, and other substances during the production process, which results in dye wastewater, mostly containing salt, chloride or bromide, microacid or alkali, metal ions, sulfur containing high chemical oxygen demand, high color, and dry-induced toxic refractory organic wastewater. Now let's look at the physical principle. So because the ratio of 5-day biochemical oxygen demand and determination of COD by potassium dichromate is less than 0.4 and the biodegradability is poor, the salt content in the wastewater will further reduce the biodegradability of the wastewater. So the physical method is often used as the pretreatment method of dye wastewater to facilitate the recovery of dye molecules from the wastewater itself. And this reduces the content of salt and metal ions and increases its biochemical. So the physical methods used in the field of dye wastewater treatment includes absorption method, membrane separation technology, and magnetic separation. Lastly, I'll talk on the chemical methods, which mainly include electrochemical method and advanced oxidation method. Electrochemical methods have high energy consumption, high cost, and electrode storage disadvantages inside reaction, such as oxygen evolution and hydrogen evolution. Electrochemical methods can be divided into electrochemical reduction and electrochemical oxidation. Besides that, there is electrocoagulable electrical floating, and so on. Advanced oxidation technology is a new water treatment technology in recent years. Hydroxyl radicals with strong oxidation can be produced during the treatment of this technology. Organic molecules that can stabilize many structures and even be difficult to be decomposed by microorganisms are converted into non-toxic and harmless biodegradable low-molecule substances. The reaction end products are mostly carbon dioxide, water, and inorganic ions, and no excess sludge and concentrate are produced. So to conclude my presentation, with the rapid development of industry, the production of dye wastewater has increased year by year. Dye composition is a complex process involving high concentration, high color, and it is difficult to biodegrade. And according to the chemical structure, Dyes are mainly divided into 8 categories, such as azo dyes, and according to the application dyes, it can be divided into 14 categories, such as reactive dyes, acid dyes, and so on. The treatment method of dye wastewater includes physical method, chemical method, and biological method, among which biological method is economical and practical. So that is all from me, Miss. Thank you.